Intermolecular attractive forces in liquids are the forces between particles in a liquid. And to understand this, you'll want to have a good background in what it means to have a physical change of state, what an endothermic or exothermic process is, how to do a Lewis-Dot structure, and how to determine a molecule's shape and its polarity. We want to talk about intermolecular versus intramolecular. Inter means between. So these are, we're talking about between molecules. So if here's a molecule, happy face, here's another molecule, happy face, we're talking about how do they feel about each other. What's this interaction? It's not a very strong interaction. It's much weaker than a chemical bond, so there's not a huge amount of energy required to break that interaction, and that we're essentially breaking intermolecular attractive forces when we change physical states. So when we melt something and we go from a solid to a liquid, we are having to overcome a certain amount of intermolecular attractive forces. On the other hand, intramolecular forces, those are forces within the molecule. So when we talk about water, for example, it has a bond between an O and an H. That is a chemical bond. It is an intramolecular attractive force. It is within the molecule. These are strong. It takes lots of energy to break them, and in fact, we would have to undergo a chemical reaction to break them, because we know that when we make or break chemical bonds, we're changing the chemical identity of the substance, so we'd undergo a chemical change. We are, for the most part today, going to talk about this type of force, so between molecules. There are three types of intermolecular attractive forces, and I will often refer to them as IAFs because it gets tiring saying intermolecular attractive forces all the time. Like I said, there's three. There is the London force. These are come from nonpolar molecules. London forces actually exist in all of our molecules, but often the type of question that will be asked is to identify the strongest force. And so when we're asked to identify the strongest force, London will only show up for nonpolar molecules. Hydrogen bonding is an intermolecular attractive force that comes from molecules containing nitrogen and hydrogen bonds, fluorine and hydrogen bonds, or oxygen and hydrogen bonds. When we just talked about water, it has an OH bond right there, and because it has that within the molecule, we would say this has a hydrogen bonding intermolecular attractive force. Now here's where it gets a little confusing. Somebody decided to put the word bonding in this intermolecular attractive force, but it's not a bond. It is a force between molecules, and because it's between molecules, it's not a bond. I know, the maximum confusion right there. The third intermolecular attractive force is dipole-dipole, and this would be the strongest intermolecular attractive force in molecules that are polar, but molecules that do not contain NH, OH, or FH bonds, because if they contained one of those, then they would be classified as hydrogen bonding. What kind of intermolecular attractive forces exist in NH3, CH4, and PCl3? Well, in order to arrive at an answer, we need to draw the Lewis-Dot structure for each of these so that we can see what kind of bonds we have and whether the molecule is polar or not. So I'm quickly drawing Lewis-Dot structures because I know that you are already familiar with them, and if you're not, go back and watch the video on Lewis-Dot structures. That will be helpful. Okay, so there's my NH3, my CH4, and my PCl3. And what I notice is that in this molecule, I have NH bonds. So therefore, I definitely have hydrogen bonding, intermolecular attractive forces. Neither of the other molecules have an NH, OH, or FH bond, so I know that they don't have hydrogen bonding. I notice that CH4 is symmetrical and therefore nonpolar, and so therefore its only intermolecular attractive force will be London. PCl3 is not symmetrical. It's a trigonal pyramidal. We know that that's a polar molecule. It does not have NH, OH, or FH bonds, so therefore it is a dipole-dipole intermolecular attractive force. Now, remember I said everybody has London forces. So CH4 had only London forces. PCl3 has those dipole-dipole forces and it has London forces. NH3 has hydrogen bonding and dipole-dipole and London. It has all three of them because it's a polar molecule and it has the ability to have London forces as well because it has polarizability. So this exercise is just getting you to think and be aware that, okay, while I'm generally going to label these only according to the strongest force they have, which would be hydrogen bonding, London, and dipole-dipole, we want to be aware that they actually do have some other forces that are occurring at the same time. So, what is the strongest intermolecular attractive force present in each of the molecules listed below? Now we're just looking to identify the strongest one because we can see that that's what the question asked me for. So, CH3F is, I have 3 hydrogens on here and 1 fluorine. Notice that the hydrogens and the fluorines are not connected to one another. So while there are H's and F's in this molecule, they are not bonded together, and so this molecule does not have hydrogen bonding. It is, however, polar, so therefore this has dipole-dipole forces. H2O, we just talked about how it has an OH bond, so it has hydrogen bonding. CH2O, when I draw the Lewis-Dot structure, has an H and then has a double bonded O. That's a polar molecule, so but no OH, FH, or NH bonds, so this would be dipole-dipole.